Every brilliant, complex response you've ever gotten from an AI like Kimi isn't actually the result of conscious thought. I know it feels like it, but it's really something far stranger and honestly far more mathematically beautiful. Welcome to This Explainer. Today, we're pulling back the curtain on Kimi K3. We're going to dive right into its underlying architecture, break down the magic, and see exactly how this incredible tool operates in pure mathematical reality.
So, the big question. Is there a little brain in there consciously considering your prompts? Absolutely not. Here is the non-negotiable truth. Kimi K3 is a large language model. At its very core, it's a massive neural network. It doesn't actually know anything in the human sense. Instead, it runs unimaginably large mathematical operations based on hundreds of billions of tunable parameters. You can basically think of these parameters as tiny, highly adjustable knobs that were meticulously calibrated during its training phase.
To show you exactly how it pulls off this illusion of knowledge, here's our roadmap for this explainer. We'll look at 1. Predicting the next token, 2. Mastering context, 3. The mixture of experts, and 4. Shadows of human knowledge. Let's get right into it.
Starting with part 1, predicting the next token.
Okay, so the absolute fundamental truth of large language models is that they simply calculate probabilities for what word comes next. That is literally it. Let's see this in action. Imagine we feed Kimi K3 this prompt. In 2026, artificial intelligence has become. Behind the scenes, these words are immediately converted into what we call embeddings. The text is transformed into numerical vectors, basically mapping out mathematical points in a ridiculously high-dimensional space.
Now take a look at the probability distribution generated by that processing. For the very next word, indispensable leads the pack at 23%, but ubiquitous and essential are really close contenders. And here is where it gets cool. The AI doesn't just automatically pick the highest number. If it did, it would sound incredibly repetitive and robotic. Instead, the model essentially rolls a mathematical die to sample from these top options, which introduces a bit of controlled randomness. That is exactly why you can ask Kimi the exact same question twice and get a slightly different yet completely valid answer every time.
Moving on to our second core concept, mastering context.
Predicting one word is great, but how does a model handle long, complex sentences reading left to right? This is where the magic of self-attention comes into play. Imagine a sentence describing a dog, a cat, a mat, and then the phrase, play with it. To a machine, knowing what it refers to is a really hard problem. Through attention, each word creates queries that scan past words' keys. Think of it like a massive matching game. The stronger the mathematical match, the more attention the model pays, drawing a definitive vector line that connects the word it directly back to the dog.
And Kimi K3 actually takes this a step further with something called multi-head attention. Imagine multiple attention mechanisms running in parallel. So you've got one tracking pronouns, another one looking at verb tenses, and another maintaining the overall logical flow. It's exactly like having a dedicated team of grammatical specialists analyzing the sentence simultaneously. Without this mechanism, the AI might spit out text that is technically grammatical, but completely devoid of meaning. Attention really is the engine of coherent context.
All right, let's jump into part 3, the mixture of experts.
This right here is arguably the secret sauce of Kimi K3's incredible speed and efficiency. How on earth does it manage such a massive scale? Well, instead of reading every single book in a massive library to answer just one question, imagine a ridiculously smart librarian. This librarian, which is called a gating network, instantly knows exactly which 3 or 4 specialized experts to consult for your specific query. So, depending entirely on your prompt, completely different clusters of experts light up inside the model. If you ask Kimi to write a Python function, the coding experts activate. Ask it to explain quantum entanglement, and the physics experts fire off. Need to translate a phrase into French? The linguistic experts step up to the plate. The gating network acts as a traffic controller, dynamically routing tokens only to the exact specialists required.
To put that into perspective, this results in a frankly mind-blowing efficiency metric, 10 to 20%. For any single token generated, only about 10 to 20% of the model's total parameters actually activate. This sparse activation is exactly how Kimi K3 can boast hundreds of billions of parameters while remaining lightning fast. It achieves high-quality reasoning through specialized routing rather than brute-forcing the math through the entire massive network every single time.
And finally, part 4, shadows of human knowledge.
So let's bring it all together. When you hit send, all of this happens in a unified, interconnected flash. Step 1. Your text is tokenized and embedded into mathematical space.
Step 2, it flows through transformer layers where those attention maps compute the intricate relationships between your words. Step 3, the mixture of experts routing directs the flow to specialized networks, and a response is probabilistically sampled. And the crazy part? All of this happens in under a second. The intelligence you're experiencing is ultimately a compressed, statistical shadow of human knowledge dancing rapidly through silicon.
It is not conscious, guys. It's not thinking. But it is undeniably a mirror. It's reflecting human patterns that are so complex and so highly coherent that they feel exactly like real understanding. And that leaves us with this final thought to chew on. The question isn't whether AI thinks. The question is whether the patterns it produces are useful. And as we've seen from digging into the underlying math of Kimi K3 today, those patterns are fundamentally powerful. Thanks so much for joining me on this explainer. I really hope this deep dive made the magic just a little more mathematical for you. Catch you next time.